Hello guys and gals, my name is Dr. Pettis at Dr. P Learning. At this channel, I teach project-based and hands-on CTE and STEM content. We focus on engineering-based projects, CAD, and 3D printing. If that is of interest to you, you're at the right place. Please like and subscribe to the channel so you can be notified when a new lesson is published. Okay, so let's get into today's lesson.
I am so excited for this next video. This is one of the students' favorite challenges. In this video, it is the famous Nightlight Challenge. I hope you're excited for this lesson today. It's going to be a great one. Again, you're going to be setting up an automatic night light. You're going to need an LED, a photoresistor, and a 10 kilo ohm resistor. Your resistor pack should say something like 10K on it. That's 10 kilo ohms. 2 gray breadboard jumpers, and then 4 jumper wires. You will need a red one, a black one, a green one, and an orange one. And I picked these colors specifically for a good reason. So if you can go ahead and pick these 4 colors of jumper wires, that would be fantastic. If you need to take a couple of minutes to get your jumper wires and all of your components, go ahead and do that now. Again, you're going to need an LED. It doesn't matter what color you choose. If you want red, fine. If you want blue, fine. Green, white, I don't care. Your photoresistor or your light dependent resistor. A 10 kilo ohm resistor. This does matter though. And then 4 of these jumper wires. So go ahead and take a minute to grab your components. Okay. All right. So as you can see, I'm going to go over some breadboard basics here. Looking at your breadboard, you'll notice that there's a plus and that there's a minus. Okay, all of the pluses from here to from one side to the other are all connected. So what that means is that if I connect power to this side from my Arduino, okay, from like say pin, we'll use pin 12, there will be power that runs all the way down to the other end. Okay, and it's the same thing with ground. If you decide that you want to run your ground wire right here, just as good a place as any, you will have ground access through this entire column. Not the most exciting thing, but it is pretty cool when you're able to really be flexible with where you connect your power and your ground. Okay. The other thing is that these rows are also connected. So row 1, row 2, row 3, all the way down to row 30. In the middle of your breadboard, there's also a divider. Okay. Right down the middle. It's a little difficult to see on this. Let's see if I can get this to show up just a little bit better. It's actually a groove. Maybe this is the best way to see it. There's a groove down the middle here. Okay. This is where the Arduino is divided. Okay, that's just plastic in the middle there. Okay. See that? Okay. So that means that these two sides, this side and this side, are not connected to each other. What else is not connected are these, like row A, row B, row C, row D, these are not connected. And then also plus and minus are not connected to one another. So these, if you look down here in the bottom left at the PowerPoint, these are not connected to one another. These are also not connected to one another. Alright, keep that in mind as you're developing or putting together your various projects. Okay? Alright. Let's see. We're going to go ahead and move on to the next slide. Just another example of these items that are connected to one another. Okay. We're going to go ahead and set up our breadboard and our Arduino. I'm going to go ahead and turn this sideways. I'm going to move these. I'm going to actually move these components out of the way. I'm going to really zoom in on this as much as I possibly can so you can see exactly what is going on. Okay, so you've got your components, and again, at any time you can pause the video and to make sure you have things set up right. So the first thing that we're going to do is we're going to get our LED. It's going to go on the plus side, or the long stem is going to connect to pin 12, okay, for our power, on row 11. So we're going to connect the long side, a little difficult to see, I'll put my hand under it, the long side, which is this side, to row 11, and the short side to row 12. You'll also notice that I have my breadboard jumpers, power to row 11, ground to row 12. Okay, just like we have here. Plus power, row 11. The short side is going to be connected to ground, and we're actually going to connect that to ground with a 10 kilo ohm resistor. Your resistor might be blue, your 10 kilo ohm resistor might be brown. As long as it's a 10 kilo ohm resistor, doesn't really matter. One side is going to connect to row 12, the other is going to be to row 18. So row 12 and row 18. Okay, row 12, row 18. It looks like it's row 19, but it's because this is bowing out. This is actually row 12. Yeah, there you go. You can see that a little bit better now. And then the last thing we're going to connect is our photoresistor, which is row 18, and the other side is row 20. So row 18, row 20, just like that. Okay, I'm going to actually bend this so you can see that just a little bit easier. Okay, all right. Should be able to see that all right. Again, I already have my power and my ground connected right over here. I'll go ahead and put them next to each other. Okay, ground, power. Now you've got two other wires. One's an orange wire and one's a green wire. You'll notice that the row 18 A0, I have this color green. Oops, sorry about that. Have this color green, so we're going to go ahead and plug this green wire. One side will go into A0, so find A0 and plug it in. It's actually on the opposite side of the Arduino. Okay, A0, and then the other side is going to go into row 18. So row 18, boom. Okay, and then our orange wire is, after this gets into focus, sorry about that. The other side is going to go into connected to 5-volt power, so 5V. It's also on the other side of the board, so it's going to go into 5V, and the other side is going to go into row 20. Again, every jumper wire that we put corresponds with some part of one of our components. Row 20 is one side of the light dependent resistor. Row 18, where our A0 is one side of the light dependent resistor, one side of the 10 kilo ohm resistor. Our ground is on row 12 with the short side of the LED on the other side of the 10 kilo ohm resistor, and then our power from pin 12 is going into the light. Okay. All right. So again, take your time. Make sure that you have this set up correctly. Go ahead and pause the video. Do that now. You can come back in a few seconds and continue the video. All right. So I'm going to go ahead and make this window just a bit bigger here. This is our code for this setup. Okay, you can have this set up correctly, but if your code's wrong, it's not going to work. Vice versa. Your code can be right, but if your breadboard is or your Arduino is set up wrong, it's not going to work. So they both have to be set up correctly in order for them to work. So we're going to be using a photoresistor or light-dependent resistor to turn on and off an LED. So we're going to start with our pin assignments. Okay, so our LED is going to be into pin 12. I've tried pin 13 before, but because there's already a resistor on pin 13, it doesn't operate properly. The other side, the other pin assignment we have is A0. Remember, the green wire was plugged into A0. You can put 0 here, or you can put A0. It doesn't really matter. I'll put A0. The next part of the code is our variables. We will have two variables. One is our base, and the other is threshold. I'm not going to dig deep into base and threshold right now. Just going to tell you that we're going to set up these two variables that we'll talk more about later. But threshold basically is like a speed limit. If you pass the speed limit, you can get a ticket. Okay, well, you're not going to get a ticket if you pass this speed limit. In this case, if you pass the speed limit, the light turns on. Okay. The next part is we're going to declare inputs and outputs. So notice earlier that I have LED and LDR. Now our LED, I can call this whatever I want to call it. If I want to call this George, I can call it George. If I want to call it Frank, if I want to call it milk, if I want to call it leche, it doesn't matter what I call it, as long as I call it the same name throughout the program. Okay, so down here when I set up our inputs and our outputs, I have to make sure that I use this same name. If these two names are used, the code it'll actually tell me there's an error and that I don't have these. It's not finding this name up here in my setup. Okay. So our LED is going to be an output. Basically, any light source, any light really is going to be an output. So if you flip the switch in your house, a light turns on. The light is the output. The light-dependent resistor, what happens is it's a resistor that's activated whenever it takes light readings, and if the light falls or the light goes away, basically, then it sends a signal to a light. Okay, so it's an input. It takes something in. It's saying I'm taking in information. The information that I'm taking in is that there is a high light condition or a low light condition. Okay, and then you're also going to set up base. So base, what it does is it's actually reading the light dependent resistor. It's taking a base reading. Okay, all right, so what's going to happen in the next part of the code is our loop. Okay, it's going to read the light this part of the code is for our setup. It's going to read the light dependent resistor and compare it against a threshold and send the output to the LED. If the light dependent resistor senses a low light condition, then the LED will light up. If there's plenty of light, then the light won't come on. Okay, that's basically what's going on here. If the threshold, if the reading that I'm taking is above the threshold, right, then the light will be in a high state. Otherwise, the light will be in a low state. Okay, it's going to take a reading. Okay, so right here, takes a reading, compares the reading if light, if external, means light around me. If external light is low, LED turns on. And then right here, if external light is on, LED stays off. And then you want to make sure that there's a delay for proper sensor operation. So sensors need to have a real quick, just let me take a quick break. Okay, that's basically what this is. And then that's really it. Okay, so I'm going to go ahead and minimize this. We're going to go ahead and make sure that this sketch is working. Okay, so we're going to verify the sketch. Everything should be good. I'm going to change this back to its normal state. Okay, alright, I'm going to go ahead and plug in my Arduino or my Iligu. I'm going to make this zoom out just a skosh. Alright, so I'm going to go ahead and upload my code. Alright, so uploading, done uploading, great. So I should be able to put my hand over this sensor and then the light should turn on, right? Okay, let's hope that works. Before you do that, we want to make sure again that this is all set up correctly. Red wire to pin 12, black wire to ground on Arduino and to negative column on breadboard. Green wire to A0 on Arduino and row 18 on the breadboard. And second red wire, the orange wire, is 5 volt on Arduino and row 20 on the breadboard. Okay. And just so that you can kind of see from the side, that's what the 5V would look like. This is what the analog 0 will look like. Okay. And then this is pin 12 and ground. Pin 12 and ground there. So if you needed to get a better angle of what that looks like. I know the tension is rising. Is this thing going to work? Okay, so we're going to test this out in just a minute. So what should happen is that if this light dependent resistor is not covered, then you can see that it's not covered here. So the moment of truth, does this actually work? Drum roll. And it works. The light turns on. My finger goes over this. I turn it, take my finger off. Covered. Covered. Now let's do something. Let's change the threshold to 10. It actually might. It actually, without my finger even being under, it might actually stay on. This means that it doesn't take as much. Okay, no, it's still. But see, my hand is significantly above. I mean, my hand, you can't even see my hand covering the. My hand is almost eye level to me. It's probably about 18 inches, right? And it's triggering this. Now in the other case, let's see if 5. Let's see what happens with 5. Let's see if it actually just. Okay, it's still going to take a little bit of effort. I'm literally like almost 2.5 feet above it, and it's flickering on and off. Okay, so as the threshold gets lower, So a lower threshold, what that means is that the light will turn on easier. Okay, so you can do 100. Okay, so let's try 100. That means it'll need to get dark, need to get. So my hand's about, oops, you can't see it, sorry. My finger's about half an inch above. Okay, so you can change these numbers. What does that look like? How does it affect how this sensor operates?
I want to thank you for visiting Dr. P Learning. Please remember to like and subscribe to the channel. We will see you on the next lesson.